Hello everyone, this is part 2 of a two-part series on solving trigonometric equations. In the last video we covered equations containing trigonometric expressions that had only arguments involving coefficients of 1. In this video we'll cover situations where the argument has coefficients other than 1. As we did in the last video, the best way is to just dive in and solve some of these equations because we already have all the skills built in previous videos that are needed to solve these. So we notice here that the argument here is 2. We solved equations where this argument was 1 in the last video, so we need to see how this 2 that's being multiplied by x is going to affect our solutions. Now, the range of values that we're supposed to be looking at are given for x, not for 2x. So the first thing we need to do is to find out, when we go around looking for solutions, how far we should go, because the 2x here should make a difference, and that's exactly what we're going to do first. So basically we're going to take this 3-part inequality, and since we want 2x, we'll go ahead and multiply all 3 parts by 2. So we get 0 less than or equal to 2x less than 4 pi. So we're going to be looking around the circle, going around twice for places where the cosine is 1/2. So starting at 0, as we go up, we know that the first place where the cosine, which is the x value, as you know, is 1/2, is going to be pi over 3. And as we go around, we notice we're not going to find any more in this region, because in the second and third quadrants, cosine is negative. So the next one we're going to find is going to be all the way in the fourth quadrant, and that's going to be 5 pi over 3. So, but then we get to 2 pi, that's going around 1 time. But remember, we need to go around twice. So let's go ahead and write those down so we keep track of them. So we know that 2x can be pi over 3, or it can be 5 pi over 3. Now we continue moving. So here we're at 6 pi over 3, or 2 pi, right? So the next one that we're going to reach is going to be 7 pi over 3. So as we go on, that's going to be 8 pi over 3, 9 pi over 3, 10 pi over 3, and we come to 11 pi over 3. We need to stop now because the next item here is going to be 12 pi over 3, which is 4 pi, and that's where we need to end our search. So we have the values where for 2x, where cosine is going to be 1/2. But remember, when we solve an equation, we don't solve for 2x, we solve for x. So now we need to go through and multiply all of these by 1/2 to get the values of x. In other words, we're multiplying both sides of this equation by 1/2. And of course, this is not a single equation, this is several equations. One is 2x equals pi over 3, the next is 2x equals 5 pi over 3, etc. So we end up with x being, again, remember, we're going to multiply each of these by 1/2. So we get pi over 6. Next we get 5 pi over 6. then we get 7 pi over 6, finally 11 pi over 6. And that's it. And that's how you handle coefficients other than 1. That's the basic strategy. So make sure that, as simple as this is, you fully understand it before we proceed. All right, so here we have another problem involving an argument with a coefficient other than 1. This time it's 3. Notice we're dealing with degrees this time. Doesn't really make a whole lot of difference as to our approach, but we do need to find out where to look. So we're going to be multiplying this by 3, therefore both of those by 3 as well. So if x is between 0 and 360 degrees, we know that 3x is going to be between, well, 3 times 0 is still 0. 3 times 360 is 1080. So basically, we're going to be going around the circle 3 times looking for places where this equation is satisfied. Let's solve it for sine 3x. So we get sine 3x equals 1. So we're looking for locations where the sine is 1. And we know sine is the y value. So we know the first value is going to be right here at 90 degrees. So 3x can be 90 degrees. Now notice that we're not going to find another place where the sine is 1 until we go a full circle around. So 90 plus 360, that'll bring us to 450. And then once again we can go around again, and so we need to add 360 to 450, and we end up with 810. So 810 degrees. Now if I go one more time around, I'm gonna violate the zone I'm supposed to be looking in, because I'm only supposed to go up to 1080. And notice that if you add another 360 to 1080, you're gonna go to 810, you're gonna go to, let's see, notice you're gonna go above 1080. So we're finished. All we need to do now is to remember that when we solve an equation, we're solving for x, not for 3x. So we're going to go ahead and multiply both sides of, remember, these are actually 3 equations, but we can handle them simultaneously. So we're going to go ahead and multiply all the values on the right as well as the left side by 1/3. So on the left side, we end up with x, and on the right side, we end up with 30 degrees. 450 divided by 3 is 150, and 810 divided by 3, let's be safe and calculate that. I believe it's 270, but let's be safe. So 810 divided by 3, yes, 270. So 270 degrees, and that's it. Those are all the solutions that are going to satisfy that equation. It's always a good idea when you have time to plug them in and search to make sure. I mean, quickly, 3 times 30 is 90. Is sine of 90 equal to 1? Yes, it is, etc. So you can check these very quickly. So make sure you can handle this simple problem before we proceed. All right, so here we have another scenario. Let's go ahead and isolate the tangent of 3x. So we get 16 tangent of 3x equals 16. Of course, we can go ahead and divide both sides by 16 and just end up with tangent of 3x equals 1. So let's find out how far we need to look. Again, we have 3x. So if x belongs to 0 to 2 pi, that means 3x is going to belong to the interval from 0 to 6 pi. So basically go around the circle 3 times, hunting for places where the tangent is 1. Now, we know that the tangent is 1 right here because the sine and cosine are the same. The only other place on the circle where the sine and cosine are the same is going to be straight across right there at 5 pi over 4. So we start with our 3x being pi over 4, and then it can be 5 pi over 4. But remember, we can keep going around the circle, right? So that's 5 pi over 4. Then we're going to go back here. So in other words, add pi to that, right? So that's 4 pi over 4. So 9 pi over 4 will bring us back here. So add another pi. And that's going to bring us to 13 pi over 4. We can add one more. That'll bring us to 17 pi over 4. Make sure we're still not reaching that. 17 over 4, that's less than 6. So we can go one more. 17 pi over 4 plus 4 pi over 4, which is just pi, is going to be 21 pi over 4. So now that's like slightly more than 5, right? So 5 pi. So we know if we go one more, that's going to be too much. So because 21 pi over 4 plus 4 pi over 4, which is pi, is going to be 25 pi over 4, and that's way more than 6 pi. So we stop, and now we just need to find the values of x, because remember, these are values for 3x. So to get the values of x is very simple. Just multiply the left side by 1/3 to get x, and each of these by 1/3. Remember, these are basically 1, 2, 3, 4, 5, 6 different equations that we're writing in compact form. So x can be, now remember, we're going to multiply each of these by 1/3. So pi over 12, 5 pi over 12. The next one will be 9 pi over 12. Next we'll have 13 pi over 12. And then 17 pi over 12. And finally 21 pi over 12. So we do notice that a couple of them can be reduced. Notice on the 9 pi over 12, 3 goes into 9 3 times, into 12 4 times. And in the 21 pi over 4, 3 goes into 21 7 times, and into 12 4 times. So to present the solution in a professional manner, let's go ahead and make a solution set. We didn't do that for the previous couple of problems, but it's always a good idea to do it. So we can just put pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. So now we cleaned it up and did all the simplification, and those are all the values that are going to make this equation true. So it's very simple, it just gets a little bit of getting used to, so make sure you practice before we proceed. All right, so here we have another equation. We're going to go ahead and isolate the cosine of 2x first. So we have square root of 2 cosine 2x equals 1. So that means cosine of 2x equals 1 over square root of 2. You may recognize that, or you may want to rationalize that denominator before you recognize it. You should recognize both forms of 1 over radical 2, which the other one being square root of 2 over 2. You should recognize both of these as being the values associated with pi over 4. So we need to now notice that we're asked to find all the solutions, not just going around the circle once or twice or anything like that. We don't have that finite range of values we're supposed to be considering. This time we want all the solutions of this equation, so we don't have any restrictions. So we're going to go through and see where the cosine of an angle is square root of 2 over 2 first. So we notice that we have one right there at pi over 4, and remember, in this region cosine is negative, so we don't need to look here, but we do have another one here at 7 pi over 4. So since we want all the solutions, we know that we can start at pi over 4 and keep going full circles around, either counterclockwise in the positive direction, or we can go in the clockwise negative direction and get other solutions. So one set of our solutions is going to be 2x equals pi over 4 plus 2 pi n, and the other set is going to be starting here and continuing to add full circles. So 2x equals 7 pi over 4 plus 2 pi n. For in both cases, of course, for n belonging to the set of integers. Okay, so again, these are solutions for 2x. We want solutions for x. So again, we're going to multiply both sides of both of these sets of equations by 1/2. So we get x equals, when I multiply pi over 4 by 1/2, I get pi over 8. And when I multiply 2 pi n by 1/2, the 2's cancel out, so I just get pi n. For n belonging to z. And the other one, when I multiply this side by 1/2, I just get x. This side gives me 7 pi over 8 plus 1/2 and 2 cancel out, so we get pi n again. Again, for all n belonging to z. If you want to present it as a solution set, you're going to write solution set is all x such that x equals pi over 8 plus pi n, comma, or x equals 7 pi over 8 plus pi n, and then we can put a semicolon and then say for n belonging to z. And that's a nice professional way of presenting your solution. As you can see, these are really simple, but do get some getting used to. So make sure you understand that, and we'll look at another one. All right, in this problem, we can see that we have a half angle for the first time, and we are looking for all solutions. So let's go ahead and isolate the variable term. So we have 6 sine of x over 2. We can go ahead and move the -3 radical 3 to the other side, so we end up with equals 3 radical 3. And let's go ahead and divide both sides by 6, so we get sine of x over 2 equals 3 radical 3 over 6. So sine x over 2 equals square root of 3 over 2. As is the case with all of these, first we'll solve for whatever expression we have here, then we'll go ahead and see what we need to do to just solve for x. So right now we're solving for x over 2, so we want to know x over 2 equals what, so that the sign of it is square root of 3 over 2. So we want the y value to be square root of 3 over 2. So as we start here and go up on the circle, we notice that the first place where the y value is square root of 3 over 2 is obviously pi over 3. And we don't want to look down here because here the sign values are negative, but we do know that we have another relative of pi over 3 in this quadrant whose sign or y value is also square root of 3 over 2. So we say x over 2 is either pi over 3 plus, remember, if it works at pi over 3, it's also going to work if you go a full circle around, again this way, again this way, or again the other way. Doesn't matter, you can go in either direction, full circles, and you'll get to angles which have the same sign. So pi over 3 plus 2n pi for n belonging to z. We also have that x over 2 equals, remember the other place where the sign is square root of 3 over 2 is right here at 2 pi over 3. So also 2 pi over 3 plus 2n pi for n belonging to z. So the last thing we need to do is just go ahead and solve for x, because we have solved so far for x over 2. So this time, instead of multiplying by a half, we need to multiply by 2. We need to multiply both sides by 2. So we get either x is equal to 2 pi over 3 plus, be careful here, you have to multiply that by 2 as well. So we get 4n pi for n belonging to z. And the second equation becomes x equals 4 pi over 3 plus, again double that, 4n pi. And that's for all n belonging to z. So you see how simple these can actually be. All right, seems like a break from our last couple of videos that were extremely long and detailed, but they're very important nevertheless. All right, so make sure you understand this and then we'll proceed. All right, so believe it or not, we have actually come to the last problem of the set. It's a very short set compared to, as I said, our last couple of videos. So notice here, we're trying to solve this equation, and we're solving it for x values between 0 and 2 pi. So we're back to a limited zone that we should be looking into. And so as we go around the circle, where do we find the sine and cosine to be the same? That's what you have to be thinking about. Before you do, however, you do need to keep in mind that this time we have a limited interval to look into. So this time we do need to go to see how far we can go with x over 4. So we're going to multiply both sides of this by 1/4. So if x belongs to the interval from 0 to 2 pi, 1/4 x, or x over 4, is going to belong to the interval from 0 to 2 pi over 4. Notice 2 pi over 4 is just pi over 2. So really, we can only go, as far as x over 4 is concerned, we can only look between 0 and pi over 2. See how interesting that becomes? Now, between 0 and pi over 2, there's only one place where this sine and cosine are the same. So we don't actually ever make it this far to also include this one, because we're dealing with x over 4. So we're only going to go with pi over 4. So we're going to say x over 4 equals pi over 4. And now all we need to do is solve for x. So that means we're going to multiply both sides by 4. So we end up with x equals pi. Again, a very nice, simple set. I hope you enjoyed it as I did. And practice until the next time that we meet. Be safe.